Welcome to AMIT'S Tuition Center. Today we will start with the exercise 8.3 of class 10, chapter number 8. So we will start in this video. We will start with question number 5. The fifth question is prove the following identities. In this question we have to prove the equality between the left hand side and the right hand side of the equation. So before doing this question, first of all we have to know about the reciprocals of some trigonometric ratios. That is, sine should be written in the form of cosecant. That is, sine theta is equals to 1 upon cosecant theta. These are the reciprocals of each other. Sine theta is the reciprocal of cosecant theta, and cos theta is the reciprocal of secant theta, and tan theta is the reciprocal of cot theta, and the same is will be for the cosecant theta. Cosecant theta will be written as cosecant theta is equals to 1 upon sine theta, and secant theta is equals to 1 upon cos theta, and cot theta will be equal to 1 upon tan theta. These all are the reciprocals of each other. That is, cos theta should be written like 1 by secant theta, and secant theta should be written like 1 upon cos theta, and the tan theta is written as tan theta is equals to sin theta upon cos theta, sin theta upon cos theta, and this cot theta is the reciprocal of tan theta. So we can write cot theta is the reciprocal of tan theta is cos theta upon sin theta. Before doing this question, we have to get the knowledge of all these reciprocals of these trigonometric terms. Sin theta should be written as 1 upon cosecant theta, and cot theta should be written as the cos theta upon sin theta, and tan theta should be written like sin theta upon cos theta. And learn these three trigonometric identities, that is, cos square theta plus sin square theta is equals to 1, and cot square theta plus 1 is equals to cosecant square theta. 1 plus tan square theta is equals to secant square theta. I have already uploaded the video about how to learn these three identities. Please go and check that video and learn how to learn these three identities, and then we will start with question number 5th of exercise 8.3. So we will start with, in this question we have to prove left hand side is equals to right hand side. So in the first part we will start with, first of all, by the left hand side of the equation. It is given that we will start with left hand side of the equation, which is given to be cosecant theta minus cot theta whole square. Here the identity should be used, that is a minus b whole square, that is a square plus b square minus 2ab. Here in this equation a is given to be cosecant theta and b is given to be cot theta, and we will put the values of a and b in this equation, in this identity. So cosecant square theta plus cot square theta minus 2a is cosecant theta, b cot theta. Now we will write their reciprocals. As we have already learned that sin theta should be written in the form of 1 upon cosecant theta, and in this equation cosecant theta is given, so we will write cosecant theta is equals to 1 upon sin theta, and here the given term is cosecant square, so we will write with 1 upon sin square theta, 1 upon sin square theta, plus cot should be written as cos upon sin. Here it is given that cot square theta, so we will write cos square theta upon sin square theta minus 2 sin square theta cos square theta upon sin square theta minus 2 cos theta. This sign should be multiplied by this sin theta, so it becomes sin square theta. In the all the denominators are sin square theta, so we will take the LCM. Here should be sin square theta and add these terms, that is 1 plus cos square theta minus 2 cos theta. So in the numerator it is given that 1 plus cos square theta minus 2 cos theta upon sin square theta. It seems to be like an identity of, this seems to be an identity of a minus b the whole square, which is given to be a square plus b square minus 2ab. Here a square, 1 should be written here square as 1 the square, a square plus b square minus 2ab. So here we can write it as 1 minus cos theta whole square upon sin square theta. Here a should be 1, b should be cos, and this is the identity, and we will write it in the form of a minus b the whole square, that is a minus b the whole square. Now the ratio becomes 1 upon cos theta whole square upon sin square theta, and the denominator now should be written like, here it is sin square theta and the identity, trigonometric identity is cos square theta plus sin square theta is equals to 1. So we can find out the value of sin square theta is 1 minus cos square theta. So we will put the value of sin square theta is 1 minus cos square theta. This minus cos should be put on the another side of the equality sign. Here it is plus, and on the other side it should become minus, and sin square theta will be equal to 1 minus cos square theta. It becomes 1 minus cos square theta. Now look at the term at the denominator. 1 should be written as its square. 1 square is equals to 1. Here again identity is used, that in the only the denominator identity is used, that is a square minus b square, a square minus b square. It should be a plus b, a minus b. So I can write it as a is 1 and b is cos theta. So a plus b, 1 plus cos theta multiplied by 1 minus cos theta. Here it is multiplication, so we can cut this term with its square. The ratio now becomes 1 minus cos theta upon 1 plus cos theta, which is on the right hand side of the equation. So we can say that yes, left hand side is equals to right hand side. Both equalities hold, and we have proved this equation. Now we will start with the second part of this question. In this question it is given that cos A upon 1 upon plus sin A plus 1 plus sin A upon cos A should be equal to 2 secant A. Again we will start with the left hand side of the equation and we will take the LCM. LCM of 1 plus sin A multiplied by 1 plus cos A. 1 plus sin A multiplied by cos A. The denominator becomes 1 plus sin A multiplied by cos A, and this 1 plus sin A multiplied by 1, this 1 plus sin A and this cos A multiplied by this cos A. It should become cos A multiplied by cos A is cos square A, and this 1 plus sin A multiplied by 1 plus sin A becomes 1 plus sin A whole square. It should become cos square A plus 1 plus sin A whole square upon 1 plus sin A into cos A. Here identity should be used A plus B whole square, that is A square plus B square plus 2AB. This identity should be used. Again A should be 1 and B should be sin. Now we will put this identity in this equation. It will become cos square A plus A square. A is 1, sin square A plus 2AB, 2 sin A upon 1 plus sin A multiplied by cos A. Now, as in the trigonometric identity, cos square theta plus sin square theta is equals to 1. Cos square theta plus sin square theta is equals to 1. So, I will put this cos square theta plus sin square theta is 1 and this one should be added in this equation, and then 2 sin theta sin A is left and 1 plus sin A multiplied by these two ones should be added, will become 2 plus 2 sin A upon 1 plus sin A into cos A. Now I will take this 2 common only from the numerator. 2 should be taken common. In the bracket it should be left 1 plus sin A divided by 1 plus sin A multiplied by cos A. This 1 plus sin A should be cancelled out from this 1 plus sin A and the ratio becomes 2 upon cos A, and now I will write this equation like 2 multiplied by 1 upon cos A, and as I have already taught, this cos A should be written as 1 upon secant A. So cos should be written as 1 upon secant A. So the equation becomes 2 secant A, which is equals to the right hand side of the equation. So left hand side is equals to right hand side. If you have any doubts in these questions, please visit AMIT'S Tuition Center. Address is given in the description box. Thanks for watching the video. Next questions will be continued in the next videos. Please like, share and subscribe the channel. Thank you so much.